Hello, hi everyone. Good evening. Well, it's evening in Italy. It's evening in Germany as well, where Marco is hailing from. Ciao, Marco. How are you?
Ciao, Enrico. I'm quite stressed out by the Deutsche Bahn, but other than that, I'm good. Thank you.
And why is this? We can spoil the reason because tomorrow is the comeback.
Tomorrow is Kandinsky, the domain-driven design open space in Berlin that I'm organizing, and we had to travel through all of Germany today with Deutsche Bahn, which we should start modeling with DDD to make them more on point, on time.
Wow. So is Deutsche Bahn, I understand, is like the trains.
Yeah, it's the railway station.
We don't want to start this conversation with Italians.
No. Different topic, different.
Yeah. At least, I guess they are at least more punctual. So thanks for being here. This is actually the first kind of regular meetup we are having this season. We've been busy with the small talks, which Marco also was part of a couple of weeks ago, where we explored the life of trainers, basically the workshops in an informal way, which doesn't mean today is going to be formal, but it's kind of back to the slides and talk format for a while, at least for today. So with Marco, we're going to talk about building better domain models with functions. So it's a different take on the whole DDD world we've known Marco for up until now. As usual, I see lots of you answering my messages on the chat. I'll wave hand and wash hands, as Gabriele says, to Gabriele, James, Matteo, Wadzum, James, and Morten, and whoever else is there. Thanks for being with us. You can, of course, ask questions as Marco is talking this evening. And I would say, off we go. Over to you.
Okay, yeah, thank you very much. It takes a second to switch screens because I only have a laptop in my hotel here. So give me 1 second to share the screen and then show you the board which we will be working on today. So sharing the screen. Now you should see a tunnel of screens. And then I switch to the mirror board. Let me know once you see the mirror board.
We don't see the screen yet. I've seen it for a second on StreamYard. Try and share it again.
Okay, let me try to share it again. Share screen. This screen. There we go.
Oh, 1, 2, 3. Boom. Fantastic. Yeah, good now.
Perfect. Okay, wonderful. So, for those of you who don't know me yet, my name is Marco Heimeshoff, and I'm a trainer and domain-driven designer and software developer for 15 years. And I founded the German DDD community in 2013, also co-founder of the virtual DDD community in 2019, and as of tomorrow, the 5th edition of our Kandinsky conference, which is a domain-driven design conference. So I live and breathe DDD for over a decade now, which is kind of obsessed, but also a really great way to build software, which is why we're here today. So that's enough about me. I like to talk about domain-driven design and how to build better business models with functional programming. And before I start with all the slides that I've prepared, when you have any questions in between or any remarks, feel free to just open your mic, talk away, or write a chat message, and Enrico will relay that message immediately. So happy to answer all the comments, even as an interruption in between. Now, usually when we build domain models, when we try to build object models that describe our business behavior the way we need it to solve business problems, the usual way is object-oriented programming, and it has been winning as the leading paradigm for the last, 40 years now or so, since the 80s, at least the 90s. So there was some procedural programming in the beginning, and then object-oriented programming took over. And functional programming was kind of on a losing end there, but that's actually historically not totally correct. So functional programming was there in the beginning, even before object-oriented programming was properly defined. Now, depends on what you mean by properly defined, of course, right? If you're following Alan Kay's definition or others, but FP has been there from the beginning as well. And the usual difference you might hear is something like this. People make fun of these, right? Say, hey, object-oriented patterns, object-oriented programming is kind of like, you get this from functional programming lovers, right? OOP is hard because you have the single responsibility principle, open-close principle, interface segregation, factory pattern strategy, decorator visitor, and the gang of 4 pattern list is as long as your elbow, and then there's DDD patterns, patterns of enterprise architecture, and so on and so forth. And on the functional programming side, this is basically functions and another function and more functions, and you're just building functions. So that sounds way simpler. But of course, this is an over-exaggeration. It's not completely false, but it's making it a bit too simple. And the thing that is more actually capturing it is not how to build functions versus how to build objects. It's actually what that means. So let me go into the deeper presentation so you can see better. You still see the screen, I hope, in full screen mode now.
Yes, well, what people see is the 2 of us here and then the screen, but if needed, we can do this.
No, that's fine. I don't see you, so yeah, I just want to make sure that the screen is still shared. I'm going to full screen mode now. So on the object-oriented programming side of things, we have concepts of encapsulation, right? We are abstracting behavior and data that belongs together and abstract them into a class where we put data to the behavior that belongs together. This data is mutable, so you have mutable objects that can change their state over time using the methods. And internally, it's using usually an imperative programming model. So when you have object-oriented programming, you have objects with methods in imperative terms. So you say, do this, buy this, reserve this, and the imperative programming style telling the machine how to do things is what you find within the objects. So this and a few other things are the usual concepts of the object-oriented programming. Of course, it's a variety, right? This is a big field. OOP has been diversifying as well for the last 40 years. So there is multiple flavors of OOP out there, but this is the general gist of it. And in functional programming, you focus more on the evaluation of functions. So functions like mathematical functions, right? F of x means x squared. So when you put an x in there, you get an x squared back. You can use this as well with domain language and use this to describe your business behavior and business models. So in functional programming, it's less about encapsulation and bringing the data to the functions where they belong. It's more about you have functions that execute certain behavior that basically represent certain state changes or certain behavior, and you provide the data as needed when you call the functions. And the data is immutable. So instead, opposite to the object-oriented programming, where you change your internal state all the time, in functional programming, one of the functional programming patterns is immutable data by default. And you have a very declarative domain model or a declarative code model. So instead of describing what to do, you describe what it represents. So instead of saying, hey, please add 2 numbers, you would say this is a sum of 2 numbers, which is technically doing the same at some point deep in the machine, right? It adds 2 numbers together, but the basic thinking behind it and also the tooling support and the language design is different, because trying to describe things declaratively means in functional programming, if you put a function somewhere or a value, shouldn't make any kind of difference, because the function call just represents the value that would result out of it. So these are the main differences, but OOP and FP aren't mutually exclusive, and this is what I really like about it. I started building domain-driven design software first in very imperative mode in a very old legacy system, and step by step we got better and better object models out of it. But also the object models became more complex and harder to handle because there was so much business logic that had to be dealt with by the employees of the company that we were building software for. So we had employee entities in there, and they had like 500 methods and thousands of data fields, and this became a mess, and it was really hard to separate and to find meaningful boundaries. And in the end, we realized a lot of this behavior is basically just simple functions with a single invariant. Why would we put that into an object? It doesn't really need to be in there. So extracting it and using functional programming together with object-oriented programming, that was kind of like the new best thing we could find. And we will talk about this later in the talk, but just the epiphany we've had in the end was say, hey, we can really use best of both worlds whenever it applies, because it's a trade-off. It's not like better or worse to use each, but there are scenarios where FP benefits you more, and that's when we do that. And when we learn more about one of the paradigms and figure out, hey, this is what we can use now, then you do the switch. And I'm working in .NET. So in .NET, it became really easy with F#. You have C# in the object-oriented corner, and then F# in the functional, and they are interoperable, which is really nice. And I assume, I'm not a Java expert, but in Java you have Scala, and in other languages you might have other pairing languages where you can do an easy interop mode. Well, not in not in every programming language, of course, but if your programming environment supports that, that's a super win. And then again, before we stick too long on this one slide, there are many languages that aren't really object-oriented or functional. They are basically a mix of a lot of paradigms. So JavaScript, for example, is a functional programming language and an object-oriented one, and also an imperative one. That depends on how you use it, right? C# is object-oriented first, but of course you can be very functional in there, and F# is functional first, but you can also be object-oriented. So most languages aren't purely one thing. Smalltalk, I think, is like the epiphany of, hey, this is object-oriented, and Haskell is probably purely functional. But other than that, other than those extremes, usually a language supports multiple paradigms at the same time. So then we figured, okay, now that we are building functions and also objects, and we're doing domain-driven design, so we're building our domain models from value types, entities, aggregates, and all these tactical patterns prescribed in domain-driven design, basically. How can we do this, or how can we support this with functional programming? Would this be better or worse, or is it a trade-off? And yeah, to go deeper into that, let's figure out what a value type is. I'm starting with the simplest of the tactical patterns, but also, in my opinion, the best one to start with when you really start your DDD journey. So if you've seen my talks before, you know that I'm usually on the strategical end of things. So I really think that modeling collaboratively, figuring out a company structure, and figuring out your bounded content, this is a more valuable part of domain modeling. And then once that is settled, the tactical parts, the implementation architecture, become more and more important. But this talk is about functional programming, so we assume all the strategical part is being dealt with, and now we want to really build software. So while you implement, finding the right abstractions that encompass your, or that ingrain your domain understanding into code is important. And value types are the low-hanging fruit of tactical domain-driven design. So long blah blah up front. What is a value type? A value type describes and or measures something in the ubiquitous language, meaning a language that domain experts and programmers define together. So simple examples for that by Martin Fowler down here would be money, right? Or date range, or the height of a person, the age of someone. Those are all values. Those are not int or string, because there is no int or string in your domain model. By domain model, I mean the mental model about your domain, right? If I think about, hey, how high is someone, that's not a float. That is meters and centimeters. Or if you're in the US, it's yards and miles or something. But there's a certain unit to that. It's not a float. You could represent it as a float, and then you have to make sure that all the transformations work. But if you try to represent hours and minutes as a float or as an int or two ints, well, now you have a problem, because there is no 99 minutes in the hour and stuff like that. So you need to build better data types. And even a string does not exist in your domain usually, because a name is not a string, right? A name can be null, a string can be null or empty, a name cannot. So based on that, the value types are the primitive data types of your domain, and they should be immutable, because value types measure something and the measured thing cannot change. Well, now the language is kind of hard here. The measured thing, of course, can change, but the measurement is a thing that exists in of itself. So if I have 3 meters, 3 meters can never change. If you add 5 meters to 3 meters, you have 8 meters, but 3 meters are still 3 meters. You didn't change what 3 meters is. So a value object that contains 3 meters should never update, because someone else knows, hey, this is 3 meters and I can work with it. But if you are mutating my 3 meters to something else, I now have the wrong assumption. So immutability as a default gives you the ability to not care about concurrency anymore, and to pass in your values as replacements of function calls. So you gain a lot of benefits from here. Now, if you build a value object in object-oriented programming, let's say, for example, I'm a Star Wars fan and I want to represent a freighter. There's a freighter ship in space. So how can we describe a freighter? Well, it has a name, right? It has a storage capacity, and it probably has a weapon system, but that's optional because not all of those have them. So yeah, let's build that, because this is not an entity in our domain. We don't need this to have a life cycle. We're just describing the value here of, hey, this is a freighter. Now, if we do this in object-oriented programming, we would actually call a freighter profile, and this is a name and a storage and a weapon system. And we need to make the setters private, because we don't want other people to manipulate it from the outside. Of course, the string is now a reference, and you could still manipulate the content. We can't really protect against that, which kind of sucks. And yeah, the weapon system is optional, so we make it nullable, right? And then you have to check if the parameters are valid and if the weapon system is not null. And because it's just a value, it doesn't have an ID. There is no entity here with a life cycle. Life cycles are really expensive to maintain. You need to have an ID, you need to have a database entry, you need to probably be able to audit all the changes, all that stuff. You don't need that for a value. So since it's just a value, we now need to be able to equal it with all the properties. This freighter equals this freighter when all the properties match. So we need to override get hash code and equals, and this is a very, very small class, and it's already a cluster fumble of code. It's full screen, and Mrs. here is not really happy about it. So functional programming has immutability by default, and value types are basically the basic records of functional programming. So looking at a value type, at the same value type in F# in this case, this would be a freighter profile with a name, a storage, and a shopping cart. Because those are functional types now, a string cannot be changed once it's set. You can't edit the string from because you have the reference. It's immutable by default. And the shopping cart is not nullable, and you have to check, hey, if it's null, that means it's not there, or it means there was a technical error in the database, or it could mean that there was an exception. No. It's an option type, meaning this is a functional type that tells you it's either optional none, so there is no shopping cart. It should have been called weapon system. Why is it shopping cart? It was weapon system here, it's shopping cart here. I'm very sorry about this typo. Well, this freighter has a shopping cart now, whatever that means, but it's an optional one. So it either has one or it has none. And you cannot deal with the pure string. You can't just say, hey, if the string is null, no. The string can never be null. It has to have a value. And you either have a shopping cart or you don't. And if you have one, it's of type string. If you have none, then there's no empty string. There's just nothing. And this is an explicit thing in your type system. And this is all you need. The type is done. This is how you define the type. It's automatically equality by all properties. Hashcode doesn't have to be overwritten. We don't need any kind of strange constructor checks or whatever. Like, this is it. We've defined our type and 3 lines of code, and that's gone, and that's done. So it's not that you can't do it with object-oriented programming, right? And this is pure C#, of course. I'm sure there's frameworks that help you with it. I've heard of, and now please don't quote me on this, I've heard of Lombok in Java. I'm not an expert, but I've heard people say, hey, then you can actually annotate stuff and you don't have to write all that code by yourself. So that might be a solution, but that makes you dependent on some framework now. And again, please don't quote me on the framework name. I'm not sure if that's the right one, but if there's a framework helping you with this work, cool, but then you're depending on a framework. This is pure programming language, very clean. So it's way simpler to express all the values that exist in your domain by having functional value types, like a record in this case. And yeah, then object-oriented programming languages, of course, C, oh, this is great. C#9 added records to the roster of data types you can have. So I'm not trying to advertise F# here, just functional programming has some things to offer. And now the bigger programming languages see, hey, this makes sense, so they incorporate it. So the whole idea here is it's not either or. Pick the best of both worlds that fits in your model. I still prefer using a language where this is a first-class citizen than using the already okayish but not perfectly representations of that in C#9, but that's technology specific. So let's ignore that for now. Yeah, so before we go to aggregates, are there any questions so far?
No questions. We have a comment from Badun. I'll show it.
Shoot.
saying Java 14 introduced records for that, in my honest opinion.
Awesome. Yeah, thanks. So same opinion that I had with C#9, right? If you have a record for that, that's exactly what I'm talking about. I'm not advertising to use F# here or saying the one language is better. It's about the patterns that work in these different paradigms. Functional programming is not like a thing that is enclosed and you have to do it fully or not at all. And object-oriented programming is also not a set that you need to do it fully or not at all. Both paradigms have a list of things, a list of patterns in them that are useful, and a mixed match of both is really highly valuable. So records, purely immutable data types that are basically, from a DDD point of view, value types, so ingrained in the programming language that you don't have to build a framework around that, that's amazing. And if Java 14, 17, forgot it, if that is in Java now with a record type, great, go for it. Like, that's exactly what I want you to do. Having an optional type, having a record type, that makes your constructor simpler. You don't have to overwrite all the hash code stuff, and you don't need to take care of the mutability in the background. That's cool.
Okay, on the go, Fabrizio, F# is amazing. That's good. I want to show this anyway. And then we have a question from Dennis Fake. How is F# and C# interoperability?
100%. So I'm gonna show you this a little later, or at least talk about this. But yeah, to give you the basic answer is 100% interoperability. You can call C# from F# and F# from C#. You can have functions in your object-oriented code that you're using. All you need to do is have a separate file in there, which is an F# file, and then you can write a function that you could call. Both are compiling to the same intermediate language, so it's fully compatible. Period. There's even more magic, but I'm going to show that later because now I want to go forward with how it's benefiting your domain-driven design first. Another question?
No, that's good.
Awesome. So let's talk about aggregates. So value types are the low-hanging fruit of domain-driven design. Aggregates, on the other hand, are I think from the tactical point of view, the hardest pattern to grasp, because what is an aggregate? An aggregate is not a class in of itself. It's a conceptual thing, right? An aggregate is a collection of entities and values that together form a transactional consistent behavior. That is what an aggregate is. So that sounds very abstract. To give you a concrete example, a simple one, right? You're programming GTA 5, the car game, and you want your car to move forward. So the car has lots of parts. You have tires, and you have a motor block, and you have a seat and a wheel and whatever. So you wouldn't move all these objects isolated, all the entities and values in there. You wouldn't move them isolated forward when you're accelerating the car. You want to take the whole car and move it forward, right? So you could build another class that is called car, and you put all the other entities in there. Or, well, what are you actually doing? Think about the domain model. The domain model says, when I hammer down on the gas pedal and then I steer to the left, this is what happens to the car. So you have an entity that you're interacting with, and the entity is the console of the car. So when I manipulate this, we call it aggregate root, the first entity or the one entity you're interacting with, this entity is connected to all the other entities and values it needs to move the car. The car is just a conceptual thing. It doesn't exist as a class. It doesn't have to. You have a console, you have a motor block, you have tires, you have whatever, and all that moves forward. And the aggregate, as a conceptual whole, it makes sure that the whole transaction is consistent. So it either moves totally or not at all. If you turn left, the whole car turns left or not at all. But you don't need the car class. You have an aggregate root, which is your first entity to attack, to call methods on, basically. So you would say console.turn left, console.hammer down or break, and then all the entities behind it execute together some transactional consistent behavior. This is one of the hardest things for people when they start with tactical DDD to figure out, okay, what does this actually mean and how would I design my domain object then? Because if you think about the things you have in real life, you have a customer, you have a product, you have a price, so you will build all these classes. But that's the wrong approach, or let's say that's the suboptimal approach, because then you optimize for representation of your real life mental models. But in your domain, you have a domain model. So what's important in your domain is not that the customer exists and has a hair color and dreams and also a shopping cart. But what's important is behavior that needs to be transactional consistent. So if I put stuff in shopping carts, there is some kind of rules, right? After the shopping cart has been ordered, I can't put more stuff in it. That's a business rule. That is completely unrelated to my name or to where I live. So these two things don't really relate, so they shouldn't be in the same object. Starting with behaviors, protecting transactional consistent behavior, that is what aggregate design is all about. And I'm super happy to talk about this for hours, but that's not the topic today. So just remember, aggregate design is hard if you don't know it yet, but it's very valuable, and it has a lot of surprises in it if you start. If you're already used to aggregate design, there is a great aggregate design canvas by Nick Tune, which I can highly recommend. I'm going to put that link into the chat later. But yeah, so there's a lot of tools that help you with great aggregate design. Now, what the aggregate is, and that's on the left side here, you have a lot of commands coming into your system that all attack the same thing, right? You put stuff, let's say the trivial example, you put stuff into shopping cart, you order a shopping cart, you take stuff out of shopping cart, and there's a list of things that happen because of that. And I'm not just saying you need to publish events, right? It doesn't have to be an event sourcing thing. It could also be purely a conceptual thing again. So if the shopping cart has been ordered, that's the event that happened. What you would do in your software, if you're purely object-oriented, right, is change your state. You change your state and then persist the aggregates. So now the Boolean of ordered is true instead of false. Great, state changed, that's it. Maybe you have another mutation, another subclass that is an ordered shopping cart or whatever, but you change your state and that's fine. If you are more reactive or message-driven, you would publish the event saying this happened. Both mean the same thing. But whatever happens needs to be transactional consistent. That is what an aggregate is all about. So I don't know if I can zoom here. Yes, I can zoom. So looking at this conceptually, when you say things happened in the past, right? So you ordered something, you put something into the shopping cart, and this happened. When you send in a command and say, hey, now send this shopping cart, order the shopping cart, do something, then you expect these events to happen. So this is how you would isolate and test an aggregate. And in the object-oriented world, this is quite a big class you need. But in functional programming, the aggregate at some point just becomes a function. So in my experience with aggregates, I figured in the beginning, hey, aggregates are really big. So, sorry, I'm looking always at my old camera. There's no camera up there. Let me look into this camera. So aggregates in the beginning are really big. You start to build a lot of behavior together and realize it doesn't really have to be transactional consistent. So you split your aggregates into smaller ones and even smaller ones. And in almost all cases, I mean, there are exceptions, but in almost all cases, we end up with an object that is called we end up with a method that is called do something in a class with the name something doer, and then you have like, yeah, something doer, do something. So order preventer, prevent order, shopping cart sender, send shopping cart. Like, yeah, this sounds weird. Why do we have a class name with the same description and the one method in it? And this is where it dawned on me at some point, like, yeah, aggregates in functional programming are just a function. You don't need the rest around it. Specifically, if you're already event sourced, this becomes more and more evident. So I have a method here that's called, now it's about reservation of cinema tickets, right? I say reserve seats. I provide a history of all the events from this screening, and I provide a list of seats to reserve, and this will do it. It's a function that will execute this behavior, or it will make the seats to be reserved by publishing the events or whatever, changing some mutable state of the whole system. So you reduce to a method and more until you realize I have a method that doesn't even change the internal state of my aggregate because I'm just publishing events. So at some point, it's just a function. It's just something where you put in parameters. And if you put in the same parameters, you always get the same behavior because it's side effect free by definition in a pure functional programming. You have a pure function that is linguistically expressing what it should. And this is how most of my aggregates nowadays look. There are still exceptions. There are still aggregates that need a lot of behavior, transactional consistent together, and a lot of different rules that are mutating or depending on the same internal state. And then I go whatever paradigm serves my problem, helps me solve my problems better. But yeah, most of the cases, a function works fine. And with a little bit of effort, making everything purely functional is so much easier than trying to figure out the great objects and cutting the great objects in the right way. But yeah, this is that's from my experience, and I really enjoy the flavor of functional programming. Now, I named this method reserve seats, which is pretty imperative, right? But what we really want when we looked at the differences between OOP and FP is having a more declarative style. So we want to focus on the what and not the how. I don't want to tell the computer how to do things. So here I say reserve seats, but what this represents is a seat reservation, right? If I say add X and Y, what it represents is the sum of X and Y. And well, this is, either or, both are fine, both are representing the same thing. So why care? Why bother? And the reason becomes more evident when you realize that in functional programming, functions are also just values. A function is something that you can pass as a parameter. In OOP, or let's say in the classical object-oriented programming languages like C# and Java, you have lambda functions now. You can pass in a lambda as a parameter into another function. So this is where functional programming starts to show. You can now have a pure function passed in as a parameter into a higher order function. So if I say result is divide by 2, add X and Y, my brain as a programmer, when I read this line, is now trying to understand, okay, so I'm adding these two numbers and then I'm dividing it by 2 and this is the result. Great. So I'm tracking the behavior of how it's doing that. If I say the result is the half of the sum of X and Y, it becomes simpler to understand because it shows me what it is that I will have here. And if I say half of 16 or half of sum of X and Y, well, both are the same thing, given that X and Y are, for example, both 8. But it doesn't matter if you add a behavior or if you add a value, because a function, if you resolve it, just as another value. So what we focus on with domain models in functional programming is fitting well together because we're describing what the things are that we get from a function call. And that's, well, actually, it's multi-paradigmatic what we're working here with because we use both paradigms still. But this leads to way easier to understand code. It represents the mental model of the domain experts better. Because a domain expert usually says, hey, I need the sum of all the monthly spendings. They don't tell you, I need to add every line item until I have a sum. Like, no. They tell you what they need. So that's the mental model of the domain experts. That should be represented in code. This, of course, goes both ways, right? If the domain experts really have a mental model that is activity-based, by all means, don't tell them to be declarative, then bring the activity into the method, because it's not about sticking to the paradigm, it's about serving a domain purpose, solving a domain problem. Oh yeah, now we go to architecture. Yeah, questions in another minute. So let's go to architecture. CQRS and event sourcing. I'm assuming most of you have heard of CQRS and event sourcing by now. If not, hey, you're in for a little treat, and Google this and really watch a lot of videos about this. This is an architectural pattern that will change your life if you haven't tried it yet. So just a quick recap, CQRS and event sourcing means that you separate your models from a one domain model you've had in the past, where you send commands to execute behavior, and you also ask questions to get some information. You split this now into two separate object models, totally separate models that are basically independent or just very, very lowly coupled. So you have one object model here with aggregates and policies where you send commands in, and when something is executed, then something happened afterwards. With event sourcing, we say, okay, great, we're not storing the state of the object, we're storing what happened, and from all the things that happened, we can reconstitute our state again and again. So this would mean that the event store, a list of things that happened from a business point of view, are the source of our domain state, as well as the source of the read model, which we use to answer queries. And the read model, and that's a great thing about this, one of the great things about this pattern is, the read model could be polystructured, could be multiple architectural designs or multiple ways of interpreting data. You can have a third normal form, perfectly optimized master data for all the customer information, but you can also have a graph database for the relationships. You can have a flat map, or you can have a BI cube, or whatever you want. You can project into any kind of data storage for query purposes, so that the query doesn't have to be joining information when you ask for it. No, when you ask for data, it's already there in the format that you like. Great. So I'm not going to go deeper into CQRS and event sourcing now. If you have questions, all open to it, but it's not about that pattern directly today, but about what this pattern means in context of functional programming. So CQRS and event sourcing has been gaining a lot of popularity from the early days it came up in 2008 or 9 up until now in the DDD community, because you can express your domain models so clearly and semantically by saying, hey, this happened when this happened, and I send in this command. So when the shopping cart has been ordered and I send order shopping cart, the aggregate says, hey, ordering denied, already ordered. And then there's an update in some supporting screen saying, hey, this idiot is trying for the second time to order his shopping cart. Man, send him a letter, please. So this becomes very semantic and therefore very useful in domain modeling. Now, object-oriented, this is an aggregate, right? It's a list of entities and values working together. And these are also objects. It's data transfer objects. So you're sending messages into the domain. And this is either a third normal storage or maybe even object model. But in functional programming, we can make this even simpler. A lot of the things you see in CQRS are basically functions. So events are the atoms of our domain, and any state we have only exists because something happened, right? So shopping cart opened, stuff put into shopping cart, stuff removed from shopping cart ordered. Now you know how the state looks. You can go through the list of events and that interprets into a state. So in object-oriented program, we would do it like this. This is one prototype here, right? Not the only recipe, but this is how it would work. You have a cart state class, and this would get in a constructor an initial cart state, usually an empty cart, but it needs to be some initial object. And then you say, here's a list of events. Basically any kind of data transfer object that represents an event in your domain, like shopping cart has been ordered as a class name. And then you have to check if it's not null, and then you take all the events in the event stream and you apply the event through a method which is then doing whatever state change needs to happen to represent what just happened. So that's quite a bit of code, but still it's understandable, but it's a bit of orchestration and it's imperative. In functional programming, you have this line down here. My state is a left fold, which is a nice functional pattern to go through a list of things and apply them on a certain entity or on a certain, that's now dangerous, on a certain value. So we have an apply function, which I didn't expose here, which is the same as this, right? You say when this event comes in, then you do something. And this apply function goes into a parameter of the list fold. And you have an empty card, which is my initial value, and I have a list of domain events. So this line of code here is basically a fold function, which takes, for all intents and purposes, takes 3 parameters. And you just call list fold apply card empty domain events, and now you have a state. The big difference here is card empty, the card will not be mutated within your program. There will be some magical intermediary states, of course, during the apply method, but in your programming, you never have a mutable thing. You always get something new out of it, which is immutable again. And list fold is a higher order function, so you can change the methods you put in, you can change the data type of whatever the initial thing should be, you can change the list of events. You just have a list fold. This works for all lists of events, or for all lists of whatever you want to work in. The only thing is that the apply method here, or the apply function here, needs to be able to deal with the domain events from here. And with one line of code, you have your state represented. So let's look at I call them the Fantastic Four. Now that you've seen an actual line of code, I'm going to show you the 4 different signatures of functions that you need when you want to represent any kind of business behavior, which makes the domain modeling really, I wouldn't say simple, but it makes it really easy to grasp what you're working with at the moment. And the rest is basically details or infrastructure. But if you look at the CQRS, there is different behaviors here, or different interpretations, or different. That's dangerous because the word is already used here. You have different function signatures that you can use to interpret different areas here. So let's start with the first one, the intention. The intention is usually what happens in the head of a person, so you wouldn't really code that. Basically, it means there is a state in your system or in the real world, right? And from this state of information, there's a book that I haven't read. You have an intention and send a command. Now, I'm still putting it here because a lot of intention gets automated over time. So things that users are doing right now because they need to have the intention, whenever the price is lower, you have to buy stuff. Great. You can automate a lot of those decisions by building either a rule engine or an AI or whatever. But yeah, intention is a function that has a following signature. Put a state in, get a command out. And that's it. So you can build an intention. Now you could make it concrete. Can I edit here? No, I can't, sadly. So you could edit it and say, I'm not calling it intention, right? Intention is just the idea that I'm conveying here. But you can call this what it is, like the need to always have a green garden. And then you put in a state of garden state. And if the garden state is under a certain threshold of greenness, you'll put out the command saying, okay, now whatever you do with a brown garden, paint the garden, and the command goes out to the system. So that's intention. Behavior, that is what you've already seen, right? There's a list of events happening in the past. When you send in a command, events pop out. That is what aggregates are doing in the OOP design. Now, a behavior is a function if you provide two parameters, a history of things that happened, which is a list of events, and a command, new events come out, new things happened. That is what happens here. Then you have the interpretation, meaning a list of events become a state. We've just seen that with the left fold, right? You have a list of events, you fold them, and they are either the object state of your domain or they are the state of your read models. You can interpret with a single signature. And last but not least, we haven't talked about this, but the policies here, whenever something happened, automatically you should react by doing the following. Not as a person, but as a system. So automation is if an event happened, then send out a command to someone else to deal with it. Or if you deal with it yourself, you publish another event like, okay, and then this happened as well. These four signatures give you all the transformations that happen here, including the human intention, if you want to automate that. So you could build an application full circle using these four different function signatures and plugging them into each other all the time. That is really powerful because it's so simple and it covers everything that you can think of in language. Now, the trick is to not call these functions behavior in your actual implementation. Call them what they do, seat reservation or whatever, right? The examples we've already had. Now, before we leave CQRS and event sourcing, did any questions pop up in the meantime?
Wonderful timing, indeed. So I'm gonna show this on the screen by the time it's fake again. Thanks for that. Are you able to see the question?
No, I see my own screen. I just have one monitor, sorry.
Okay, so using CQRS, how do you prevent your domain from getting trapped in a self-maintained framework? There's often so many technical details, even store, even bust, that this seems bound to happen.
Yeah and no. So this is a question I wouldn't want to go too deep into right now, but just the quick overview is I wouldn't use a framework unless you really understand the trade-offs. The thing I usually depend on is an event store because I don't want to build my own database, right? I did that in the past, and colleagues of mine did that for years. You can do that, of course. You can just build a database table in your SQL storage called event store and build everything around it yourself, but that's horrible work. So there is event stores out there, right? Geteventstore.com or events.com. That's a for free product, which is industry grade. That's a dependency I'm happy with. It's like an SQL database. You're not mad about that either. So that's not a problem. But your domain model, looking at this graphic here, right? Your domain model that is publishing events shouldn't depend on something like Kafka. It should have an interface with a clear language that says publish events or publish list of events. And this interface can be implemented by anything that can send a message. So if you build a good interface around all these areas that are colorful here, if you build a good interface between command sender and the adapter of your domain, that's hexagonal architecture basically, you can have a method call in between, or a Kafka, or a RabbitMQ, or a ZeroMQ message, and you can change this decision later anytime you want. So you're not coupled to something. The idea of the CQRS framework, of the CQRS structure is this is a pattern, it's not a framework. If you buy a framework or use a framework which gives you all this functionality, you're now coupled to all of their trade-offs. But the idea of, hey, I want to send a command to an aggregate, yeah, you can build that yourself. That is so simple. It's a simple thing. You want to have an API where you say, hey, server dot get this message, and then on the server you have something that says, hey, I got this message, how can I put this into the domain now? That's port and adapter pattern, basically. And of course, behind that API, you can use Kafka, Rabbit, whatever you like, even the Axon framework, or use a CQRS framework if you like. But I would always abstract by building my own API first, so making the whole system basically injectable so that the infrastructure becomes something you can dependency inject, and then use the function. So say publish events instead of calling Kafka.streamtopic.something. That's the short answer, right? The details in reality are complex and or more complicated than that. But yeah, my go-to way would be, don't depend on a framework unless you really understand what you're doing and you see the trade-off is worth it for your case. But many people try CQRS by using a framework first, and that's very costly. But it depends, and please don't take it as a preaching, right? I'm not saying frameworks are bad. It's just, as you said already, it feels like you're tying yourself in. With CQRS, you don't have to. You can make a different choice for every message layer. You can have RabbitMQ between command and aggregate, and you can have Kafka for publishing events and subscribing to it, and nobody's hindering you. If you have a clean API, and the API basically needs to be send command to specific endpoint, publish event to everybody who wants, subscribe for all the data streams, and request reply pattern for the query and response, and maybe a notification stream when a read model updates. That's it. If you build that infrastructure through APIs, you can inject any technology you like, and you can change it later. That makes it really cheap. Another question?
Cool. Yeah, we have from the time is fake again. Would you say your domain events are monoidal?
Ooh. I don't know, and I'm afraid to answer that now. So I would say my domain events are records. My domain events are nothing more than just something that has information. I'm not sure what you're getting at by asking if they are monoidal. So I mean, you can map them, filter them. Not sure. Don't have to think about that. Thank you. I'm going to pass that question for later.
Cool. And this was the last one. So if you want, carry on.
Go. Oh, that was the last one. Okay.
Yeah.
So then we talked about CQRS and event sourcing. Now let's talk about the model view update pattern, which is a functional front-end pattern, not a back-end, right? CQRS and event sourcing is, well, back-end, front-end depends on where you stand and look, but CQRS and event sourcing are usually used for domain behavior in complex business systems, so the classical back-end system. And the model view update pattern came from the Elmish programming language, so it's often called the Elm architecture, ELM, that would be. So the abstract pattern is over here on the left. You have a model, and this model is basically any kind of record. It's data in a certain structure that says, hey, look, here's an immutable data structure describing everything you need to see on screen. So if you're Facebook, this is, you have your photo, you have your name, you have a list of comments, and so on and so forth. That is a data model. This model gets injected into a view function. So you call, hey, render or view this model. And then declaratively, this model says, hey, if customer logged in, then button green. If customer not logged in, then button red, and stuff like that. So you have a declarative view method, which is basically taking the data model and interpreting it in a visible thing. Sorry. Then from this view, when something happens, let's say in a browser, right, you have a DOM event, you click on a button or so. What we do is we send a message to the update method. Function, I'm always saying method, sorry for that. You have an update method that has two parameters, the momentary model and the message that has been sent. And the update method function has all the behavior. So it will send a new model into the system and say, look, this is our new model now. Because something happened, now we're logged in, for example, and then you have a new model. You're not updating the old model, that would be mutable state, right? You are replacing the whole model with a new one. So this is a unidirectional method flow for functional front ends. And this is how it would look, to give you a little fun side story here. But to make it more digestible, you have a model which is some kind of representation. It's the stick figures, right? And they get rendered as a certain view. and then you pass a message and say, look, do this, do that. And then you have an update function that says, I'm taking this message and the momentary model, and now there's a new model which gets rendered as a view again. I really enjoyed this when I tried Elm as a exercise, basically, and with F#, that was beautiful. There is something called Fable.io. I'm going to show a link later. And with Fable, you can actually use the Elmish architecture in your functional front end in .NET and build websites in this manner. And then the most beautiful thing was we figured out, well, there is a side effect canal, of course. The update method a function needs to be able to say, hey, the user deleted something or wrote an article or whatever. This needs to go to the backend, right? So it's not only a circle that is closed. We need to ask the backend for data, like, hey, can you give me the starting point when I log in or whatever? Give me all my comments to show them on screen. So I can ask queries to the backend system, and I will get answers that I then use to update the model. And when the model says, when the update method function says, hey, look, you are doing something that has an effect on the real world, not only on this front end, you also send a command basically to the backend to say do something. And if this leads to a change in the information of the backend system, it will inform the front end again. So you have this, now it's not a perfect 8 that I drew here, but that's only because my screen is not large enough. But you have this wonderful infinite one-directional message loop between back and front end. And, well, the backend is written in, let's say, functional programming, CQRS, and event sourcing, purely reactive message-driven system. And the front end is now a functional-driven, purely message-driven, reactive, and so on and so forth. It's a theme on both sides. You're using different models because here you have concurrency and more data, and you need to represent large amounts of information. In the front end, you have user experience as a concern and other things. So you're optimizing for different areas. But in general, the general gist of it is unidirectional message flow in a functional system where everything is just reactive. And this is so beautiful. This works hand in hand. If you use model view update in the front end, CQRS and event sourcing in the back end, you can send the same command that the server can understand from the front end, and you can use data from the back end. Of course, you need to do some mapping in between, right? Because your front end is probably JavaScript, your back end is whatever, C#, Java, whatever. So there's a little bit of mapping, but that's infrastructure layer. Unless you have something really cool like Fable.io. So this is something, I don't know if anything like this exists in the Java world or in any other world, but Fable is a transpiler that gives you industry-grade JavaScript, I would say. So it's, if you build a type system like this, and this is now describing a card game, right? It's the face, color, and describing what a card is in F#. And these are actual compilable types. So this is a face is either card, ace, queen, jack, and so on. The color is spades, hearts, diamonds, clubs, and the card is a face and a color. So this is how you would describe these types. And these types can be used in the backend when you're having .NET Core or .NET Framework using F#. And they can also be used in the front end in a, how do they call that, isomorphic application. You can use the same types and even the same functions. If you're writing behavior in F#, Fable will transpile it, which is F# Babel, by the way, hence the name. So when you go to Fable.io and you are working in .NET, you can try it on the website online. It has super easy starting pages to get hooked. And yeah, I've been building all my front ends for the last 5 years for the last 4 years with Fable.io. So this makes it easy because now you can actually reuse your types. If you have information, looking back at the graphic here, if there is some data like, hey, the cars that have been sold last week you have the amount and the name and whatever, those are records with specific subtypes. The exact same types work in your front end now to render your front end. That is so freaking beautiful. So you don't have to rewrite logic and make some unit test around it to figure out if the behavior is the same for validation or whatnot. It becomes an isomorphic application. Front end and back end become best friends again. That's great. I really enjoy that. So yeah, enough about those whole application approaches. So all of that what we've talked about before now is the big architecture things, right? CQRS, event sourcing, how to build the bigger system. But there are still some more really neat details in functional patterns. Pattern matching, for example. When you have algebraic data types, like product types or sum types. In F#, this is called a discriminated union. We've just seen it here. We said a type color, which is a type, right? This would be a class in object-oriented programming. But it's not an enumeration. It's not just, hey, color has one of these fields, but it's actually subtypes. So the type of face is either the type of ace, king, queen, jack, or it's number, but number has values in it. Jack does not have values in it. So the closest representation would be you have some superclass, which is abstract, which is called face, and then you have implementing classes, which are called ace, king, jack, and number, but number has an int as an internal field. So this would represent it the closest, I think, but not fully. There's a mismatch. So if you have these kind of types, you could say, hey, match my card with now ace and hearts, because we know, looking back at the type here, a card is a face and a color. So if I say ace of hearts is a value that I want to generate, I say it has ace, comma, hearts, by that generating a tuple. And the wonderful thing about F#, what I really like, is it makes you type, it is strongly typed, so this is not some dynamic thing here. This is actually a tuple now of two types, which are color and face of the specific subtype, ace and hearts. And because it can be inferred, there is no other way how you could mean this line. You don't have to write new tuple of face and color, brackets open, ace and hearts. You can just omit all that because it's obvious. And the compiler knows it, so the compiler will make it work. As long as you do anything that is not type safe, the compiler won't let you do it. So it's super strongly typed, and it leads you along all the mistakes you make. But it makes your code very, very readable, and that's what I really enjoy. So I have an ace of hearts here, and I have 10 of spades, which is the number 10. And number, if you look at it, number of int, right? So if I say number, I need to provide an int, so it's number 10 and spades. And I now can say match card with, if it's ace hearts, I print ace of hearts on the screen. If it's anything and hearts, I say, hey, a lovely heart. If it is the number 10 and spades, I'm going to print 10 of spades. And if it's anything and diamonds or clubs, I'm going to print diamonds or clubs. Now, this is like a switch case statement, switch case on steroids, right? It gives you not only, hey, if it's this specific thing, but you can actually peek into the values that you're matching, and you match on certain patterns. But, and this is one of the powerful features here, pattern matching tells you, hey, warning, this is incomplete. You are not matching all the patterns. So there are things that could happen. For example, underscore and spades is not matched in here. So please cover all the patterns. And the trick that we did in our business is we made this a compiler rule. Say, hey, if this happens, make it red. You're not allowed to compile your program when you have a pattern matching that doesn't cover all cases. This is beneficial if you, for example, have a list of events in your event store, right? And a list of types those events could have. So there is shopping cart opened, put stuff into shopping cart ordered. Great. Now you match on all those events to project your state. And then you realize, oh shit, you can actually take stuff out of the shopping cart, and you're adding this event to your events discriminated union. So you would have a type events with all the events in it, right? If you add one, now your compiler will tell you all the places in source code where you're missing this specific case. So you cannot forget to handle it. In your projections, in your backend for the read models, and in your domain model, that will be handled now. In your front end, your representation of UI and all that will be handled now. Your compiler will guide you along all the errors you've made, or all the places you didn't change yet. That is super powerful. So I really, really like that. One of my favorite features in functional programming, and specifically in F#. Now, another thing, and I'm looking at the time, trying to rush a little, but not too much. Another thing here, don't have to understand the content. That's not important. It's just a demonstration from some website. The meaningful white space. This is not functional programming in general. This is F# specific, so I'm not going to linger on that too long. But instead of having a lot of brackets and colons and stuff like that, you have meaningful white space. If it's indented, it means it belongs to the thing above. So you have a new type here, that's the type. You have a method, everything below it is the method until you arrive at the next thing at the same indentation. this, on the one hand, is easy on the eyes, right? As a human being, I can read, or let's say in Western culture, where you read from top to bottom and from left to right, this becomes very easy to understand, and you don't have to figure out, oh, this bracket belongs to this bracket, belongs to this bracket. You're getting rid of a lot of the noise. It's a kind of a acquired taste. In the beginning, I found it hard because I'm used to building long lines, right? And the brackets helped me. So I was used to a different way, but you get used to this way easier. And in the end, it gives you a simple overview. You look at code and you can immediately tell where you are. So meaningful white space makes your code easier to understand. And you can even show non-developers code. Well, this example is kind of bad because it's doing just a little bit of technical thing. But you can show if this is business code, you can show people business code, and it would make sense to them. Now I stopped my full screen. That's not what I wanted. Anyway, let's go back to the presentation. There we go. So now the last few things here. Pipes are better than brackets. This is one thing that I enjoy deeply. That is the way you can compose functions. So what do I mean by pipes and brackets? Of course, not the depicted pipes and brackets. Those are just placeholders. What I mean is you have brackets usually when you say you want to do things with things that do things with things. So you have a list of droids here, and you gather the droids, right? And then you dismantle the gathered droids, and then you deactivate the dismantled droids, and then you store them. So this is how you smuggle droids. Now we defined a function. Great. That's F# code working. So can we make it more readable? And there's a really cool thing in, I need to stop my presentation. There's a really cool thing in F#, which is the piping system, which is something that I use for domain modeling, basically, because it makes the story readable like it's a human story from the domain. What I would say here is I'm going to take the droids, and what do we do with the droids? We gather them. So there's a pipe operator saying whatever comes from before, which is a list of droids, put that into this function. And now what you usually would write, if you look at object-oriented programming languages with a lambda, right, you would define something like x becomes gather x. Yay, this is how this would look in C# or Java, I guess. Now you can omit that because there is one parameter, and that one parameter is the one you put into the function. So we can query that in there and say, hey, the compiler will understand this. There is no need to say, yeah, the one thing becomes the one thing. That's obvious. So because it's obvious, this is all you need. So you say, take the droids, gather them. After you've gathered them, dismantle them. And then you get the point, I hope. You deactivate, and so on and so forth. Let's not go to the end now because it's just code. So writing code like this, having white space that is meaningful and piping stuff into other things, gives your eyes an easy way to follow along, and you can tell the story by going through the screen and telling the story that you see there, instead of starting with the innermost brackets and then going back outwards. So I really, really, really enjoy this visual feature. Now the last two things, let's say the last thing for this type system for the functional types is measure types. If you have a measure type, for example, you can just define a type called M and a type called S by putting measure in front of it. Now you have a measure type, which is really cool for value objects that don't have any behavior, that are just a measurement of height or age or time or whatever. And you can define values, say distance is 12.0, and then you put the value type in brackets. And if you say I want to have distance plus time, well, it's two different values, two different measures, right? You can't add minutes and seconds or meters and seconds. So it tells you an error from the compiler, hey, this doesn't work. But if you say distance divided by time, you'll get a new measure type, which is meters per second or m per s. That doesn't mean that the compiler understands what a meter is or a second is conceptually, but it understands, hey, these are measures and you can divide them, and now you have a divided measure. So if you have a function somewhere that wants to have a velocity, something with meters per second, you could actually put in distance divided by time and give that as a parameter. So you can build very simply your own system, even if you're just working with floats, but you can build a measure system around that. That is also pretty powerful if your domain has any kind of measurements in it. And now, the last thing to bring everything together. The hexagonal architecture. If you've worked with domain-driven design before, you've probably heard of hexagonal architecture. So the idea here is, instead of having a 3-layered architecture where you put database at the bottom, domain in the middle, UI at the top, or any other kind of archaic old architecture, which is still the predominant architecture in most legacy systems today, which is a weird thing to say. But anyway, getting away from the 3-layer architecture and protecting the domain, because it's the most valuable thing, to make the domain independent of anything. So these squigglies and triangles here, those are my objects or my functions from my domain model. And my domain model should not know that it is being used by a database or instantiated by a service, or that there is a UI calling it, because my domain model is the behavior, the classes, the functions that represent my domain understanding. When a business expert says, hey, if you have a reserved seat and you want to add another seat, there needs to be at least 2 meters in between. Great, that's a business rule. The domain expert didn't tell me anything about SQL or throughput or message Kafka or whatever. That's all not part of the domain model. So my domain model, the actual object model or functional model that I'm building, shouldn't represent all these technical concerns, shouldn't also be dependent on that. Because if the domain model is the most valuable thing in your business, you should protect that. You want to protect that. So that's where hexagonal architecture comes in play. It has nothing to do with 6 sides. It's just because there is multiple adapters and ports you can stick into this. I don't know who invented the hexagon. I think it was Alistair Cockburn or so. But never mind the hexagon. It could also be a squared architecture or an onion architecture. I've read that before. Or clean architecture. They all refer to basically the same pattern. The domain is pure. It's independent from all the rest. And you have an adapter, multiple adapters even, that know how to instantiate and call things in the domain, and how to take data or behavior out of the domain and send a message, persist on hard drive, whatever. But the domain does not understand that. So a simple pattern here is from the CQRS world, for example. A command handler would be a great adapter here. If you say there are commands here coming from the outside world, boom, boom, they say order shopping cart. There's an adapter here that says, great, let me load all the events from a shopping cart. And now I bring the object to life. And now I know which function or method to call in the domain by giving it all the events and then reconstituting state. And once the behavior is done and the domain did their rules, now we can publish what happened by sending it on the cable. That's what the command handler would do. Now the accept order, of course, like I have an accept order command here, which is just a data type, right? This is object-oriented class. In functional programming, this would be a record. So there's not a big difference, except you have immutability and all the type safety and all that up front by default. And then the handler would say, hey, if there's a command coming in, I'm going to check authorization. I'm going to reinstantiate the class. I would call the accept order method on this class, right? And then do persistence and message bus. That's what object-oriented programming would do. Now, I've told you before in the very start of the talk, we could do OO or we could do FP, right? But the best thing is to do best of both worlds. One of the most successful patterns is having a functional core within an object-oriented hull. So if you build your infrastructure in an object-oriented way, because most programmers are used to it, most tooling is supporting that, you might have all your frameworks in place already. So the object-oriented hull makes your whole system tick. All the ports, adapters are object-oriented, or in whatever way you have written them before. But then instead of calling customer.acceptNewOrder, which is object-oriented, I would now go ahead and build my order handling as a functional module. In C# F# world, this would be I build an order handling F# file, which is a module called order handling, and it would have a lot of functions like the accept function, which now, of course, needs to have a customer record and the order ID and so on and so forth. Because we are not on the customer class anymore, we have a behavior where you inject the things it needs to do the behavior. But it will be type safe, it will be purely functional, immutable, and all those things. And after you have your result, you can now take the result from here and then do the same thing, persistence, message bus. So this is a very easy way to start with functional programming in .NET. Just start with a single behavior that you put into a functional file instead of having it call on an object, and then figure it out from there. Next step follows naturally. So this is usually what I would have ended my talk with in the past, saying this is great, yeah, this makes a lot of sense, and we did this for years and it made a lot of sense. So this is probably the start of your journey. Please take it away from here, that's great. But if you embrace functional programming fully, if you really enjoy the functionality it brings, the simpleness it brings to development of software, I can highly recommend the SafeStack, which is an open source community building it's not a technology, it's a pattern. No, it's not. It's a mix of tools that give you a fully functional .NET environment for cloud computing, web servers, application, and front-end design, all in pure F#. And you might have guessed by now, I like F# as a language a lot. So just this teeny tiny bit of advertisement here. Try the SafeStack. It's a simple template to download. It will give you a web backend service, an Azure hosting platform, Fable to run F# in the browser, and Elmish architecture for the client-side user interfaces. So everything we've talked about is in there, and even cloud ready with a deployment script and everything. And you're not coupled to these 4 implementations. They are just the name givers. There's also AWS Lambda support and other frameworks for all the other parts of this whole thing. So you can go full bonkers functional programming all the way, and you don't need any OOP anymore if you don't want to. But you shouldn't start with that if you have never touched FP before. This might be a little bit too much in one go, but the option is here, and I can highly recommend safe-stack.github.io. So that is basically it from me. Okay, thanks, bye. If you have any further questions, now would be the great time for that. And so now that's it from me. I'm going to go back to the stream now and stop sharing.
Excellent. Thanks, Marco. That was excellent as usual. So there has been a bit of exchange in the YouTube chat in terms of like positive exchange. Questions were asked, and some folks joining the conversation already replied to some questions, so I would guess we can skip those. So I'll go on and read the first one from Christian. Actually, now you can see that, so I'll show it. So once you're done with
exactly. So in ports and adapters is one of the great benefits you can. In FP, how do you place implementations of the adapters if there are no interfaces? Oh yeah, that's beautiful. The signature of the function is the interface, right? It's the same thing as the interface. So if you have a function with a specific signature, a function, for example, that is a behavior, or that is a message interpreter, or a mapper, or whatever, there's a specific signature that needs some behavior, and you can inject that behavior as a function again. So having an adapter where you say, look, if there's a method coming, if there's a command coming in, it's a JSON command, and you need to map that JSON to a specific record type and deal with it from there. And in the future, you change your data type. You can still keep the whole thing that you've built. Now you're injecting, instead of the other mapper, you are now injecting the mapper that can deal with a new method or with a new message type. So yeah, the signature of your functions are the interfaces, because you can compose functions. You have a function that can take other functions as parameters, and you can compose very complex behavior from very simple behavior. So you start with the simplest thing, and you build your complete application service step by step from there. Period. I hope that answers your question. If not, please continue asking.
Cool. We'll see if another question from Christian comes along, because there's some time between StreamYard and the other. But in the meantime, we have Antonio, who asks, pipe sampling F# can be achieved with map chain and methods reference?
Yeah. Yes, it can. So you get a very similar structure. I used link queue in C# before. So you could say any collection of things you have, right? You can say collection of customers dot select, and then a lambda function, and then dot filter, and a lambda function, and stuff like that. So it looks very similar, but there is still a little bit of, most programmers don't care about this. So it's an optimization that you might not care about, but getting away of the clutter. I don't have to write bracket open, variable name, and then big arrow function, and then all the lambda ruffle. I just write the function name, and that's it. I can omit the brackets. I don't need brackets. I can get rid of the semicolon at the end of the line. I don't need that. Like, it just becomes cleaner because there is only a pipe looking to the right side, which is a visual sign saying this goes in there. It's a detail, but if you read 1,000 lines code and it's just visually appealing and simple and all the clutter is gone, it becomes easier. So I prefer that over a link use statement, which is already pretty good. So yeah, mapping, chaining maps and reference and filters like that would do the trick.
That's fantastic. Thanks, Marco. So Christian says, question answered. So I guess that is it. Just to remind all of you, we have this coming Friday at 3 p.m. CEST talk with Scott Blashin. I've seen his name being mentioned in the chat. So Scott is another great expert on DDD and F# particularly. Some of you were asking about it. So we have a meetup we did with Scott online 1 year ago. We have a workshop next month, but if you want to, get a taste of what it is, we have a small talk with him on Friday at 3 p.m. So be there if you can. And again, like now, it's going to be a chance to ask questions to Scott. And Marco, I guess that's it. Have a good DDD Dinsky.
Thank you.
Good to be in person, I guess.
Yeah, I'm looking forward to that really much. But yeah, highly recommend it. If you haven't seen Scott Blashin talking before, go look at his quick session on Friday and look up any videos you can find from him. So I've learned F# from Scott Blashin years ago, and I've heard of the language before. It felt kind of esoterical, right? Functional programming, who needs that? And it was Scott at Build Stuff who was just showing some slides and was like, oh my God, like all of a sudden my mind blew. Is like, piping functions, semantic naming, composite functions, like this is great stuff. This makes domain-driven design so much better. And yeah, it's a really good teacher. So enjoy. And now I have to leave and prepare. And I wish you all a good night. See you next time.
Thanks, everyone. See you soon.